You've tried using Lovable, Bolt, Replit, any of these AI coding tools, and let me guess, you got very excited at the beginning, you thought you were making a lot of progress, then you hit a level, and then it was almost impossible to get past that level. A number of bugs started to creep in, things were not quite exactly what you wanted them to be, and no matter how much prompt engineering and YouTube tutorials you watched, you never managed to get the thing exactly like you wanted. So let me tell you, this is not your problem, you are not the only one. My name is Guillermo, and I am the CTO and co-founder of a tech studio called 7 Sigma, where we build MVPs, SaaS, AI-based applications for clients. And a lot of those people interested in building software come to us with the exact same problem, which is, hey, I've coded, I've used Replit or Bolt, any of these to build software, and I almost got it. Can you guys fix it and effectively make it ready? Right? And in this video, I'm going to give you a very high-level understanding of how AI works and why these tools work the way they do and when they fall short. Because it's not a coincidence, it's built into the technology. And then I'm going to show you the framework I use to decide when to use them, when they are the most powerful, and when you need to step away from them to make sure that you don't waste your time. So first, let's understand how these tools work. Obviously, you've heard about AI, you've heard about AI agents, all of these terms that no one really seems to know what they mean. I'll tell you what they mean. So when people talk about AI nowadays, what they're referring to is LLMs, or large language models. The way these models work at a very simple level is they've been trained with a lot of data and they've learned to recognize patterns so that for a given input, they give a certain output. Why is that relevant for us? Well, when you ask them to code something, they are not really understanding what they need to code like a software engineer would. They are not really recognizing, it's like, okay, I need some sort of landing page and then user dashboard and authentication and all these things. What they're really doing is from their training data, which is a gigantic data set, they're like, okay, in the past, when I've seen an app like this being built, it typically has these components. And from the code I've been trained on, this is how these problems are typically solved. So it's a hyper powerful version of going through a catalog of solutions and plugging them into what they're trying to create, right? So that's AI and LLMs. And actually, Apple released a paper a month ago titled The Illusion of Thinking, and that's exactly what they were saying. LLMs don't really think, they're just advanced pattern matching, and the better they get, the more complex the patterns they are able to match. But after a certain point, their performance falls off a cliff. Why is this important? Well, this actually ties back to the issues you're running into when using these tools, right? So long as the things you're asking for somewhat resembles some of the things that the AI has seen on training, then it's going to be very good at plugging those things in. But if you pay attention to the results you're getting, it looks a little bit like Frankenstein. And again, it's not that you're wrong for prompting the wrong thing, is because that's exactly what it's doing. It's taking the patterns from its training data and trying to stitch together the thing you want. However, if you get past a certain level of complexity, it's very difficult to pick pieces of all the training data to make them into a cohesive thing. That's really what a software engineer would do, which is think through, like decompose the things they know and create a custom solution. AI is not doing that. AI is just cherry picking the data and plugging it in, building your Frankenstein. So I hope this shines a light into why you're running into the issues you're running into, and that's because AI works like that. Now, before we move on, let's talk quickly about what AI agents are, because that's the buzzword now. What an AI agent is really, in the context of coding tools, etc., is just a fancy word to say, well, whatever the AI decided that you should do, they're also able to do it. Like they have agency, they're able to perform actions. So what this enables is that the AI decides a course of action, they can perform an action, and then they can evaluate that, and that gets feedback into the tool, creates a feedback loop that allows it to run by itself a bit longer. Now, this solves some of the problems, because before you just had to ask ChatGPT, copy paste, and you were the one sending the information back and forth. You were the one playing telephone. AI agents solve that problem, and so you're able to run way longer. But the problem remains the same. The person commanding the actions, the agent, the LLM, is not really smart. It doesn't really know what it's doing. So hopefully, if you understand this, you're able to intuitively understand why when you try to use AI to create complex tools, you hit a threshold where the thing doesn't really get better. It morphs into different versions of the same quality of a Frankenstein. And so just as I said, the problem is not more prompt engineering. You can squeeze a little bit more with that. The problem is the AI is not capable of understanding anything else. So your only way to progress is to add more features. But the moment you start building onto the features you have, the complexity level of the product that you're building is way more than what AI can understand, because it's never been trained on a pattern similar to yours, right? And at that point, there's absolutely nothing you can do only with prompt engineering. And so with this understanding, what's the framework that I use to take the most advantage of these tools when they shine, while avoiding wasting my time on things that will never work. So there are 3 cases where they're brilliant. They will save you a lot of time that you don't need to spend. First thing is low complexity prototypes, or any software that's very flat in terms of the complexity. What would be these things? It would be static websites, something that, if you build separate pages, they don't need to talk to each other. There's not a lot of logic involved in them. And the reason for that is, even if the product that you're building grows bigger, the complexity doesn't grow because things are not interconnected. So the overall complexity of the software stays pretty much flat. Then second, visual prototypes where you focus only on the UI. If you're only trying to mock what the UI will look like and there's not a lot of interconnectivity between the pieces, you're not building a very complex tool. You're building single Lego blocks, single pieces in somewhat isolation that the AI is pretty good at placing them in the places that they should be. So in this case, you can move a lot faster than custom coding or even using design tools like Figma, because you keep the complexity very low. So obviously the previous point on this one are pretty much the same. You're trying to build something where the complexity stays low, even though the product is big, because there's not a lot of interconnectivity in the pieces. And the final use case where these tools are very useful is when you're trying to solve a problem that, even though it's technically complex, it's a problem that's been solved many, many times. It's a known problem. So something like user authentication or like known algorithms. The AI is trained on these things, so even though it doesn't have to think, it's able to pull the solution from their training data, so you're going to get the best standard solution for that problem. That's also why AI shines at passing coding interviews, because those are complex problems, but with very known solutions. So when you're trying to do anything like this, tools like Replit, Bolt, AI-based tools will shine, will save you a lot of time, and you don't even need to be technical to take full advantage of those, right? So you'll be able to create like quick prototypes, quick proof of concepts very fast, so long as you stay below this complexity threshold. Now, the counter of that is when these tools become a problem. Anytime you need custom complex logic. If you've ever tried asking ChatGPT for custom logic, unless it knows the problem he's asking for, it will fail miserably. Then anytime you need very specific guidelines to be followed, they are not somewhat standard, you'll see it struggles a lot to maintain that consistently, because it's competing between the training data and the way it knows to solve the problem and your guidelines when they contradict. You'll see that that's going to be a hit or miss. The better the model, the more it's going to follow your guidelines, but there's always a chance. And if you're working on a big project, you'll inevitably run into issues. And then finally, it's software that needs to be maintained. Software that needs to be maintained over a long enough time horizon. And that probably applies to most MVPs, to be honest, unless the MVP is a very simple proof concept. Why? Because the moment you need actual engineers, actual humans to step in, the code is not going to be very good. Why? Because it avoids all the best practices in software engineering, like not repeating yourself, creating modular code, all that. All those things are wonderful for how humans take care of code. However, AI, since it needs to maintain everything in its context, is going to repeat code all over the place because it's just taking, like, it's a Frankenstein, right? So to summarize, anything that will have logic that will increase exponentially, like you need to stack logic layers on top of each other, anything that needs to follow very specific guidelines consistently, or anything that will need to eventually be maintained by humans, you shouldn't rely on AI to build this thing. Now, I know what you're thinking. So if AI can't do these things, what should I do? And there are 2 main solutions that I've seen working. The first one is, inevitably, you'll need to become somewhat proficient in the technologies and the tools that AI is using. For example, if you're using Replit, Bolt, Cursor, V0, you're likely going to be dealing with TypeScript, you're going to be dealing with Next.js, React, Tailwind CSS, etc. If you become somewhat proficient in these tools, as your skills grow, you're able to help the AI navigate the complexities, because you as a human think very differently to AI. So you can get past that, and over time, you'll be able to maintain your own product, and the learning curve is going to be a lot faster than if you were to start without these tools. That would be the path if you have the time and resources to learn things, and your timelines don't require the product to be ready soon, but eventually you'll be able to fully own the thing that you're building. And you'll be very grateful that you learned these things. So option one is you eventually need to learn to understand what the AI is creating so that you can fix and correct the things that it's doing wrong. Now, option two is you'll inevitably need to bring in someone that knows, right? At some point, you'll hit that wall. And as AI compounds the Frankenstein and messes things up, it puts it into a more manageable form, and you can continue improving both at the same time. So those are, as of today, the only two ways to get past that thing. Now, just to be clear, all AI companies are trying to solve this problem by tweaking how AI works to effectively teach them to think. Now, when that's going to happen, I don't know, no one knows. But it's certainly not going to happen with the current architecture. But that's a topic for a different video. I hope this video was useful to you. I hope it gives you the context and awareness to make the right decisions at the right time. As always, ask any questions you have in the comments, and I will do my best to reply to all of them. Otherwise, that's it.